Hi everyone, welcome back to the channel. I'm Heinrich and I'm the real nuclear physicist. And today we'll be getting a lesson from a flat earther on time zones. The video we'll be looking at today comes from a channel called Flat Earth Banjo. And he's explaining how Professor Dave explains and Michael Sertain does not understand time zones. So let's see where he goes wrong.
So this guy, he came up with this, he uploaded a video a couple days ago and talking about the Southern Star, and I'm gonna show you his video now, and I'm gonna show how wrong he is.
Somebody facing south away from north, because this is your north in the middle there, right? Somebody facing south. This guy's facing south over here. This guy's facing south over here. All right, they're all facing away from north. And somebody in a boat here in the middle of the Pacific Ocean, okay? Somebody there also facing south. Now, they can all see the Southern Cross above the horizon when they're facing south. But for that to be possible on your flat Earth, look, it has to be there. It has to be there, it has to be there, and it has to be there. So it's sort of like Schrodinger's Southern Cross. It needs to be everywhere at the same time.
I agree. There's no time of day that it would be night in South Africa, Australia and South America. But it can be night in two of those places. In fact, take a look at this image. Now, it's nighttime in South Africa and in the bigger part of South America. And once again, the claim now still stands. If two people, both of them facing directly south, both of them will see the Southern Cross. And that only works if the Earth is a sphere. Because on a flat Earth, they'll be looking in two opposite directions.
Pointed out to him that he wasn't in all four places at the same time. He was going around the table showing the star at one place at a time. So I went to timeanddate.com, I printed this and sent to him, and I told him that the Southern Cross was in Australia only at the same time he was making that video. One of the things he said that's really crazy is this one that it says the Southern Cross is observable in exactly the same place for the entire night.
I'm guessing, Flat Earth Banjo, that you're a Northern Hemisphere chauvinist. Because, just like in the Northern Hemisphere, Polaris is mostly stationary throughout the night, as it is the celestial pole. The Southern Cross is the Southern Hemisphere's celestial pole. Now, it's not the entire cross, and in fact it's not exactly at the cross, just a bit to the side of the cross. But it stays in roughly the same place throughout the entire night. It does not move across the sky, like Orion does, or like any of the other constellations do. So, how do you explain that on a flat Earth? In fact, a southern celestial pole doesn't even make sense on a flat Earth, because what is it rotating around?
Just like saying that you observe the sun standing at the same place all day, or the moon at the same place all night. And we all know that all the luminaries move from east to west.
Saying that the Southern Cross staying at the same place is like saying the sun and the moon would stay the same place throughout the day isn't even closely accurate. The sun and the moon move because the Earth rotates. Now, there's two poles that the Earth rotates around. What's at the end of those poles if you go into space? Polaris, more or less, and close to the Southern Cross. That's why they don't go around the Earth, but they more or less oscillate around the poles. So, once again, you can't explain that on a flat Earth, can you?
But I want to show you something really interesting, and you can go to my backup channel. I just uploaded this video there. It's a US Navy video, but, made back in the 50s, I believe, talking about celestial navigation. And they emphasize that all the celestial bodies seem to move from east to west, all of them. So please take a listen to this video.
They gave this sphere a name, celestial sphere, and we still call it that today. From Earth, it appears to move from east to west, one complete rotation every 24 hours. Polaris, or the North Star, is approximately at the celestial North Pole, and the rest of the sphere appears to revolve around it. The apparent motion is common to all celestial bodies. Their hour circles are constantly rotating from east to west.
Using data from the 50s isn't really something recent, is it? Yet, this still doesn't prove the Earth is flat. In fact, on that image showing Polaris as the celestial North Pole, the line going through shows there must be a celestial South Pole, which once again can't be explained on a flat Earth. And the fact that the stars seem like they don't move, it's because they are far, very, very far away. And light takes a long time to reach us. And we'll only see how they moved by the light that reached us. So it doesn't explain the flat Earth. And in fact, on a flat Earth, you don't even have an explanation for the stars. You just call them luminaries. What does that mean? What are they made of? Where do they come from? So please get a decent explanation for your model, and maybe people would try to take you seriously.
When stars are used for navigational purposes, another reference must be used to determine their position. Stars appear to move, however, they do not change their position relative to one another.
Stars not changing their positions relative to each other is again because they are very far away. And we, rotating at a constant motion, will only see that the stars go from east to west because we are rotating. And that's not something you can explain. You don't have a model to explain why the stars are rotating.
Alright, so all stars are considered fixed because they are fixed. We don't have parallax between stars. On the heliocentric model, the star's position would change by the hour because, according to the heliocentric model, the universe is expanding.
Actually, we do. We do observe stellar parallax. If you look at a star during one part of the year, when we're at the one side of the sun, and then take a look at the same stars during 6 months later, when we're on the other side of the sun, you will see something called stellar parallax. Why? Because we're on a sphere rotating around its own axis orbiting a sun.
The IRS inertial reference system in aircraft wouldn't work. Nothing would work on an expanding universe.
The key word that you used there is inertial reference system. What does that mean? It's your inertial reference frame. It's a reference frame where the absolute motion is only your motion. So, on an aeroplane, their reference frame is they are moving. So the Earth, according to when you're in an aeroplane, isn't moving. Why? Because it's an inertial reference frame. That's why it works, because physics says it does.
So we have had the same star map, star chart for thousands of years. Stars do not move. It matches the flat Earth model observation, not the heliocentric model.
Making a claim that the stars have been the same for the last thousands of years is incorrect. In fact, because you're a Northern Hemisphere chauvinist, let's look at Polaris. So Polaris, currently the pole star, hasn't always been the pole star. The pole star, let's say 10,000 years ago, was Iota Hercules. And in about 1,000 years, we'll have another new pole star. So where does that claim from stars haven't changed position in thousands of years go now, when we've got evidence that the stars indeed did change?
And this guy on TikTok and neither Michael Certain or Professor Davis understand time zones. Those stars are never in all three places at the same time. they rotate. And the only time in the year that's possible for all three regions to see the Southern Cross, person has to be in the easternmost parts of Brazil early in the afternoon. I mean, around 6 p.m. in the afternoon, evening, around 6 p.m. in the evening. And another person has to be at the westernmost parts of Australia, in Perth, at around 5:30 a.m. And anywhere in Africa. That's the only time that the Southern Cross can be seen out those three regions at the same time.
Well, you say that Professor Dave and Michael Sertain don't understand time zones, but it looks like you're not the one. And here you go showing an image proving exactly why you're wrong. So you go draw this Southern Cross at an arbitrary point on the map and just draw 3 lines to it saying that of course you'll see them if you're in those 3 places. But go do it on a flat earth map. Then you'll see it doesn't make sense. And yes, that might be the only time during the year that you can see it from all three continents. But throughout the year, in fact daily, you can see it from at least 2 of them. And that completely destroys your flat earth model. I think that's it for today. This flat earth banjo has not shown in any way how time zones disprove a spherical earth, or how Professor Dave and Michael Sertain don't understand time zones. In fact, it looks like he's the one who can't understand reality. So if you enjoyed this video, like and subscribe and stick around with me, and I'll see you next time.